All right, let's go ahead and get started. We're learning about polar form, so we've learned about the complex numbers yesterday. Today we're going to deal with turning them into actual polar form. So here, if you notice, I'm going to move this just a little bit. Here, it says r is equal to the absolute value of z, which is equal to the modulus. That's what we called it there. So whenever you find the modulus, when you try to put it in polar form, that would be your new r. So here we have r being your modulus. Also, since we're trying to put it in terms of sine and cosine in polar form, we have a is equal to r cosine theta, b is equal to r sine theta. Remember, everything is in terms of a plus b I. So a is considered your x, or it's your cosine, b is considered your sine, or it's considered like the y-axis. So that's the two terms that we normally like to see them in. R is considered the modulus, and here theta is considered the argument. You'll see that a lot on page 598 or 598. Actually, it's 598. So they talk about arguments, meaning it's the angle measurement. And a way to find it is we know that tangent is equal to sine over cosine, but now we don't have sine over cosine. We have a and b. So it's going to be b divided by a, and that's how you can find your tangent. So there's two ways of finding it, but we'll learn as we go. And normally in the equation, we'll see as z is equal to r cosine theta plus I r sine. But now we're going to see in terms of the radius is multiplying into cosine theta plus the I of sine theta. Remember, it has to be a plus bi. So it has to be in this terms here, so we have the I and where the sine is, which is the b. In this case here. So this formula right here is what we're going to focus on. This is when we're converting it to polar form from complex numbers. So let's go ahead and do example 5. I have four different steps of what to do here. Number one is to graph it. The reason why we want to graph it is because we want to see what angle the argument is. So now let's go ahead and do number 1. So number 1, I'm going to graph it. It's 1 plus I. So it's going to be 1, remember it's negative, positive, so 1 here. Positive I is above, so it would be somewhere around here. And when we're creating a modulus, we have to create a line and a dot. We're not creating dots anymore. So we have to create that line. Here, this is when we're graphing it. This angle here, we don't know what it is, but we're going to do that in step 3. So step 1, we graph it. We know the measurement or the degree is between 0 and 90 degrees. So we're still focusing as if we were quadrants. So it's between 0 and 90, so keep that in mind. Step 2, we're finding our r. So to find our r, we know it's the absolute value of z, which is equal to, and we're going to go ahead and find it. It's a squared plus b squared. A squared is the whole number, so it's going to be 1 squared. And then b squared is the number in front of I, which is still a 1 squared. This will give us 1 plus 1, which will give us radical 2. So that means our r is equal to radical 2. We need two things to solve this and put it in terms of this. We need our radius, or r, and we need our argument, or our degree. So we found our radius is radical 2. Step 3, we're going to go ahead and find the degree. To find the degree, or find the argument, we're going to use tangent. So the tangent of this angle is equal to b over a. Let me make sure the erase this. Okay, so the tangent of the argument is b over a. We know that b, if we're looking over here, remember this is a, this is b, and again we're only focusing on number, we're not focusing on the I. So we know that it's going to be the tangent of b, which is 1, because that's the number in front of I, over a, which is 1 as well. So it's going to be tangent is equal to 1 over 1. And the tangent is now equal to 1. One of two ways you can solve for this, and I prefer just doing it this method, is if you're looking here from 0 to 90, you're focusing on these three here. You're going to divide and see which one you get until you get 90 degrees. So if we divide the first one, remember it's sine over cosine, so 1/2 divided by radical 3 over 2. We're going to get something else. If we do radical 2 over 2 divided by radical 2, we end up with a positive number. The reason why, if I do 7 divided by 7, I get 1. 10 divided by 10, 1. A million divided by a million, it's still 1. So radical 2 over 2 divided by radical 2 over 2, that's going to give us a number of 1. So that means since our tangent is equal to 1, our measurement is radians over 4. Again, also we sketched in the first quadrant. It has to be a measurement in the first quadrant. So then we found our degree, so we graphed, we found what r was, we found our argument is, and now we have to put, we have to put it in this term. So it's going to be, I'm going to write it again. So r cosine theta plus I sine theta. Now we know what r is. R is radical 2. Cosine is always as cosine, and then cosine of theta, now we have our argument. I mean, cosine of pi over 4 plus I sine of pi over 4. It's the same measurement there. All right, and that's it. Next one, negative 1 plus radical 3i. First thing, graph it. So I'm going to graph it over here. So it's negative 1. We know negative 1's over here. Positive radical 3i should be over here. Doesn't have to be exact. You just want the numbers here. And when we graph it, we're going to have something like this. What this tells us is it's going to be a degree in the second quadrant. So we can keep that in mind when we're finding step 3. So now step 1, we graphed it. Step 2, let's go ahead and square root. So it's a squared, so it's negative 1 squared, plus b squared. B squared is now radical 3 squared. If we simplify it, we get negative 1 squared is 1, and the square root of 3 squared is just 3. So 1 plus 3, that is equal to radical 4, which is equal to 2. So now our radius is 2. We found it, so let's go ahead and go to step 3. Step 3 is we're going to find that tangent, that's b over a, the angle, or the argument. So now, we have, that's fine. So tangent of b is considered radical 3, divided by a is considered negative 1. This is equal to the tangent of theta equals negative b over a. So tangent of theta is equal to negative 3 over a. Tangent of theta is equal to negative radical 3. So now we have to find a second quadrant. When we divide all these 3 here, we have to get negative radical 3. So looking at these, so the second quadrant here, we know that the second one, it can't be because they're same numbers. This one, tangent, if I divide, I'll get negative 1. Now your next 2 things is divide these 2 here. So remember, it's sine divided by cosine. So when you divide each of these, the answer that would give you a negative radical 3 is, let me see if I got it here, which I do, is 2 radians over 3. So now our degree is 2 radians over 3. And how you can check that, just divide radical 3 over 2 divided by negative 1. And you're going to end up with negative radical 3. So now we have our radians, we have our hour. So now we go ahead and fill it in. So now we know it's r cosine theta plus sine theta. So r is 2 times your cosine of your degree. Your degree now is 2 radians over 3. Plus, keep in mind, always put the I there. If you don't put I there, it's not a complex number in polar form anymore. So you have to include the I. So I sine, and it's the same degree there. And then we have 2 more here. Some more practice. So we have negative 4 radians over times radical 3 minus 4i. So we go ahead and graph first. So negative 4 radians over 3 should be in this side. Negative 4i should be in this side. So that means our degree has to be somewhere in the 4th quadrant. Now, let's go ahead and do step 2. Let's go ahead and divide. So it's the square root of your first one, so it's negative 4 radical 3, plus square root of your second one, which is negative 4. When you're squaring, keep in mind you're squaring all the factors. For the first one, now there's 2 factors, negative 4, and there is radical 3. So negative 4 squared, 16. The square root of 3, the square root of the squared root of 3 squared, sorry, that's a lot to say, is equal to 3. The reason why, the radicals cancel out. But make sure you're squaring both factors in between there. And then plus negative 4 squared is 16. Now you multiply and add it together, and you get a number that is 64. Yep, 64. then r is now equal to 8. So we found what our radius is. Our third thing now is to find our tangent. So tangent, or our argument, is b over a. We know that b is -4, a is -4 radical 3. So it's -4 divided by -4 radical 3. It's harder to do in your calculator. I prefer you doing it in hand and simplifying from there. Calculator's going to give you decimals. We don't want decimals. So now, if you look here, it looks like the -4 and -4 can cancel out. So you're left with 1 over radical 3. So if you're looking in the third quadrant, you're dividing sine by cosine. So y divided by x to see which one you get when you get 1 over radical 3. And there is a possibility there. And that possibility is 7 radians over 6. Don't put it here. 7 radians over 6. So now we have our radius, we have our argument. Now let's go ahead and put it in terms of polar form. So it's going to be r times cosine theta plus I sine theta. Our r is 8. Cosine of the angle, which is now 7 radians over 6, plus I sine is the same measurement. And that's it. That's your answer. Fourth one. This is when your angle, your argument, is not in the graph. So I'll show you what I mean by that. So 3 plus 4i. So 3 should be here, 4i should be around here. So that means your degree is in the first quadrant. For your homework, I won't have you graph it because graphing just helps you to see where the angle could be, and that's just additional help. Second step, square root first one, second one. So 3 squared plus 4 squared. You're not including the I, so you get 9 plus 16, which is 25, and your r is now equal to 5. Third step, you're finding your radius. So the tangent of theta is equal to 4, so b divided by a, 4 over 3. In the first quadrant, if you start dividing all those numbers, all these numbers here from the first quadrant, you will never get a 4 over 3. So to find out your measurement, you're going to multiply both sides by the inverse tangent. And the book left it, oopsie, I want to cancel out the theta. So the book has it in where it's the inverse tangent of 4 over 3. I prefer if you solve it out and actually give me a degree. So when you do the inverse tangent of 4 over 3, you end up with a degree of 53.13 degrees. And make sure your calculator is in degree form so you can get the proper answer. So if it's not in the graph, so it's no radians whatsoever, put it in degree form. So go ahead and solve it out by doing the inverse tangent, and you'll have your degree form there. And now the last step is to go ahead and put it in polar form. So r is 5 times the cosine of our angle. Now our angle is 53.13 plus I sine of your angle, which is 53.13, and that's your answer. Now, if we're looking over here, there's a way where we can go ahead and multiply the two. So if you want to zoom in, it's actually on your book. You don't really need to zoom in. So we have one polar form. We have another polar form. There's two ways we can go ahead and simplify them. We can go ahead and multiply them, or we can divide them. So multiplying them, all you're doing is you're multiplying the two radiuses, and then you're going to have, it's always cosine plus I sine. So your cosine, and you're adding your 2 degrees there. And then plus I sine, you're adding your 2 degrees there. So when you're multiplying, you're adding your degrees, you're multiplying your numbers. Division, when you're dividing the 2, you are dividing the radiuses, r1 divided by r2, and then your cosine, I sine, they're kept there, but now for the degrees, you're subtracting the first degree from the second one, and then plus, it's always a plus, and then your first degree minus your second degree there. So we're going to show 2 different ways on how to solve this out. Now, first one, A, we have Z1 is equal to that. Z2 is equal to that. We're going to go ahead and find Z1 times Z2. So when we're multiplying, looking up here, you multiply the 2 radiuses. So So that's 2, and that's 5. Remember, the radius is that number on the outside from the beginning of the problem. And we do 2 times 5, and put bracket, the cosine, and then when you're multiplying, you're adding the 2 degrees. So that means the cosine of radians over 4 plus radians over 3 plus I sine, and again, you're doing the same thing. You're adding the 2 from the sine. So radians over 4 plus radians over 3. And then you have that. Now, let's go ahead and simplify. 2 times 5 is 10. I'm going to put here, I'm just going to put parentheses, cosine. Whenever you're adding this, remember, you're not multiplying it. You're not doing 4 times 3. It's not 1 over 12. Think of it as fractions. So 1 over 4 plus 1 over 3. If I do that on my calculator, I end up with, I should have it here, 7 over 12. And then you always include. So just add it with fractions and add the radians in the end. So I have cosine of 7 radians over 12 plus I sine. Again, 1 over 4 plus 1/3 is equal to 7 over 12, and just include the radians with it. And then you have that. We want to go a step further and solve it out. So what we do is we find the cosine of each one. So the cosine of 7 radians over 12, I want to make sure if we put it in radians form. Yeah, you put it in radians form, so that's the most important part. So I'm going to put here radian form, or radian mode. So now if you put radian mode, it's a cosine of 7 radians over 12. So remember that radians is that pi button, but when you put in radian mode, now it's considered radians. So it's not pi. So now the cosine of 7 radians over 12, you're going to get a decimal of negative 0.2588. And then for this one, you're not including the I, you're just finding sine of 7 radians over 12. And the sine of 7 radians over 12 is 0.9659, and then you include the I. So we want everything in number form, so we'll go a step further. So we just converted this into radians form. And now, if you see here the 10, we use distributive property, and we multiply the 2. And when we multiply the 2, we have negative 2.588 plus 9.659. I. Remember, it's A plus BI. It has to be in that format, and therefore you get this as your answer. In your book, I would recommend, and I'll write it in your homework, but you have to round it within tenth place. That'll be easier. Tenths. Now I'm gonna do hundreds because they have a lot. Next one, find Z1 divided by Z2. So now you're dividing. So when you're dividing the 2 radiuses. So the first one is R1, which is 2, divided by R2. Then you have your cosine, and whenever you have your cosine, you are subtracting the first radians from the second one. So the cosine of radians over 4 minus radians over 3. So it's the first one minus the second one. Plus I sine, it's your first one, radians over 4, minus the sine of radians over 3. So you're subtracting the 2 radians. Then you have that. Now simplify a step further. 2/5, you can't simplify, just leave it as a fraction. So now we have the cosine, 1/4 minus 1/3, I got negative 1 over 12. So that means I'll have negative radians over 12. And plus I sine. Keep in mind you're adding, even though you're subtracting, you're only subtracting the degrees, not the cosine and sine. So then you're going to have sine of negative radians over 12. So then you have that. We have to keep in mind what we learned about even and odd functions. I believe I taught you at the beginning of the week about even and odd functions. The only even functions there are is cosine and secant, meaning cosine and it's a reciprocal function. Everything else, if you have a negative degree, it turns into negative. So cosine is considered even. Sine is considered odd. What that means, if you were to multiply it out, so 2/5, I get the cosine of a negative radians over 12. So although you have a negative radians there, it turns into, sorry, let me just change this. It turns into a positive because it's even. So the only even functions out of the 6 is the cosine and its reciprocal function, which is secant. But for sine, whenever you have a negative degree, your whole thing becomes negative. So now cosine is positive, and your sine now, when you're multiplied out, it's going to be a negative. So you have negative radians over 12. Again, it's not negative radians over 12 anymore. It just, the negative gets simplified to the whole thing. And for cosine, it just disappears because it's an even function. Now, next up, you go ahead and simplify out. So radians mode, cosine of radians over 2, 0.9659. Sine of radians over 2 is 0.2588, and include the I in the end. I didn't make a negative sign, I just brought the negative down, because then I will go ahead and subtract them. Now, here, use distributive property. I'm going to move over here. When you use distributive property, you go ahead and simplify them, and the steps should be really easy. So you simplify them, you get 0.2/5 times this whole thing here, 0.3864, minus 2/5 times that, I get 0.1035i. It's in the form of a plus bi. So that's how you go step by step. If you guys need more help, let me know. My email is down there. Let me see you guys. Have a good day.